Determine the conversion of the series at n go from 1 to infinity of n times sine of 1 over n. This is not a geometric series, so we won't be examining the ratio here. With this series, the general term is a sub n equals n times sine of 1 over n. And to determine the conversion of the series, one way to do this, and this is one of the many ways to do it, is to check if the limit is 0 or not. If the limit is not 0, then the series diverges using the n-term divergence test. And if the limit is 0, nothing we can say about the series. And so again, the n-term divergence test say that if the limits at n go to infinity of a sub n go to a number that is not 0, then the series a sub n diverges. But again, if the limit is 0, nothing can be said about the series. So first, we take the limit of n go to infinity of a sub n, which is the limits at n go to infinity of n times sine of 1 over n. This is infinity times 0, which is an indeterminate form, so that we can use the L'Hopital rule. But first, we would write this as a ratio 1 over the other. This is sine of 1 over n over 1 over n, because multiplying n is the same as dividing the reciprocal. We can check that this is indeterminate form because the numerator sine of 1 over n at n go to infinity, 1 over n is 0 and sine of 0 is 0, and in the denominator it is also 0. But instead of using the L'Hopital rule, observe that we have the special limit which state that if theta go to 0, then sine of theta over theta is 1. And this is one of the special limits that we learned from Calculus 1. We can rewrite this as the limits as 1 over n go to 0, because at n go to infinity, 1 over n go to 0. Sine of 1 over n over 1 over n. So we have the limit of the form theta go to 0 of sine of theta over theta. This limit is 1. Since the limit of the a sub n term is not 0, we say that the series diverges. And when we state whether the series diverges or converges, we need to name the test that we use. In this case, we would conclude that the series diverges by the nth term divergence test. Always state the name of the test that we use and the conclusion whether the series converges or diverges, along with the justification. For the series as n go from 1 to infinity of negative 1 raised to the n plus 1 of n over n plus 1, recall that the factor negative 1 raised to the n plus 1 alternate the sign. As n equals 1, the power is 1 plus 1 or 2, so the first term is positive, 1 over 2. 1 plus 1 in the denominator is 2. And then the next term is negative 2 over 3. The next term is positive 3 over 4. And the sign alternate. We suspect that at n go to infinity, the n terms a sub n is negative 1 to the n plus 1 or n over n plus 1. But regardless, if we take the limits at n go to infinity of n over n plus 1, we see that this limit is 1, so the a sub n term is either 1 or negative 1. Regardless of what this is not 0, So the series diverges by the nth term divergence test.